Hello everyone and welcome back. So today we will be performing lab 5.1, which is encrypting data at rest by using the AWS Key Management Services. So in this lab we will be using the AWS KMS Key Management Services to encrypt data at rest. We will create an AWS KMS key and use it to encrypt objects stored in Amazon Simple Storage Services and use it to encrypt Amazon Elastic Block Store, which is the EBS volumes. We will also see how AWS Trail works, provides audit logs of AWS KMS keys usage and how disabling the key affects data access. So we will be doing these following tasks, like create an AWS KMS customer managed key to encrypt and decrypt data at rest, store an encrypted object in an S3 bucket by using an encryption key, attempt public access and signed access to an encrypted S3 object, monitor encryption key usage by using the CloudTrail event history, and encrypt the root volume of an existing Amazon Elastic Compute Cloud Amazon EC2 instance, disable and re-enable an AWS KMS key and observe the effects on data access. So the duration of this lab is overall 2 hours and 30 minutes, and this lab will require approximately 75 minutes to complete. So we will try to complete it as soon, like within the 40 minutes timestamp radius here. Let us begin the tasks here. Okay. So to access our environment, I will just simply click on this green button here. It will open me in the new tab. Let's wait for it to load. Okay. Till then I will see like what is our first task. Okay. Our first task is to create an AWS KMS key here. We will create an AWS KMS key in the AWS management consoles. Okay. Let us just create a key here. Okay, our environment is here open with the Voc Labs ID here. Okay. So let me type KMS. Wait for it to load. We will choose create key. For key type choose symmetric. Okay. Here it has been loaded. We will create key. Okay, symmetric. Let me check the advanced options. KMS single region key. We can ignore this for now. Let's move on to next. So let me copy this. And we will name it as my KMS key. Okay. For now we can just move on to the next step. So for key administrators we will have to look for key KMS, search for and choose the VOC labs role. Okay. So here are our key administrators here. So let me just check for VOC labs. Okay, I have selected this role here. For key usage permissions, we will also select VOC labs. Okay, then we will click on next. So here is our JSON for key policy, which we have set up: enable IAM users permission SID, with the root privileges, and along with the allow access for key administrators effect is allow. And then next for the session we use KMS create, KMS describe, KMS enable, KMS list here, along with the KMS remove revoke, KMS delete, and tag resources. And for allow for use we are also using the voclabs ID here. So hierarchy is here, like we can edit it from here, but by on the edit icon, which we will be not using in this lab, I think so. For now, click on next. Let us review our single region key here. We cannot change when the created my KMS key is its alias here. And here are specific paths. So now let us just create the key. Okay, wait for it. Hierarchy is now created with a specific key ID value here. So now moving on to the next task, which is task 2. In this task you will download an image to an S3 bucket. You will encrypt the file by using an encryption key that you created. To download the file named clock.png to your computer, choose the downloading link. Let's open it in new tab. Okay, here it is. Let us just save it. Okay, I select here download clock. Do I have to name it here? Let me check. Wait. Download the file name clock.png to your computer. Okay, so let me just save it in the downloads folder. So now it has been saved. Okay, this is the file saved here and it opens successfully. Okay, so here I have saved the file. So now for our next task is locate the S3 buckets and analyze its encryption settings in the search box. Okay, so now we will be reverting to S3. Open link in new tab. Hierarchy is here. We are having issues finding the key. We can find it from here. So let's wait for it to load. So here we have the image buckets here. So we are in the Amazon S3 here buckets. So now we will have to select the image bucket ID file here. So let us we select it. So buckets. There we have the general purpose buckets here along with directory buckets. Okay, access is denied here, general purpose buckets. So I have opened this here. I can open it in a new tab, but I have opened it by clicking on the link here. So now in the next we will go to the properties tab and see for the default encryption. Okay, here it is. Like server-side encryption with Amazon S3 managed keys. Here we have in the default encryption we notice that the setting for it is currently disabled here. As we can see here, it is disabled. So now upload to, we will now see, now upload a file to the bucket and store it as an encrypted object. At the top of the page choose the objects tab and then choose OK. So now I went to the objects tab here. We will upload a file. We will upload the file here and then we will be applying the following settings in the properties section. Okay, so let me just upload the file. Add files, clock. So here we have the clock.png file here. So now before clicking on the upload button, we will be going to the properties of here and we will be observing upon the details here. Like from the properties tab in the server side encryption settings, we will choose specify an encryption key here. Okay, so storage properties, storage, server side encryption, specify an encryption key. Okay, and then for following that encryption, we choose AWS Key Management SSC KMS encryption key type. Okay, this can be a lot of tricky here. Like let me check, specify an encryption key type, choose. Okay, let me just encryption key type, choose ASSC. Encryption type, like override, like we don't have to mess with these settings. For encryption type, AWS server-side encryption with Amazon S3 managed keys. Okay, for server-side encryption with AWS SSE KMS. SSE, yes, here it is, SSE KMS. We will select this here, and for the next one, AWS KMS key, choose from your AWS KMS keys. Okay, so here we will, our keys are loading here. Like here it is, our my KMS key. Okay, with the specific ID here and enabled, here it is, and now we can leave it as it is. Okay, so select the clock file here, clock.png file. With these settings, we have to carefully observe these settings here for the server-side encryption, as one step missed can result in this lab test cases to fail. So let me just upload it. I think I've done this task here. Let's wait. Okay, it has been now done successfully. Okay, so the information after information will not be available after you navigate away from this page. The following information is no longer available. Strange. close this tab here. So here it is. As you can see, we have the clock.png file here uploaded. So what we did here is that the user the user requested to upload a file and store it as an encrypted object in an image bucket. Amazon S3 requested a data key from AWS KMS to use to encrypt the file. AWS KMS generated a plain text data key and encrypted the data key by using the customer managed key MyKMS key. AWS KMS sent both copies of the data to key to Amazon S3. Amazon S3 encrypted the object by using the plain text data key, stored the object, and then deleted the plain text data key. The encrypted key was kept in the object's metadata. Okay, so analyze encryption settings on the object. We will choose the link for the clock.png object on the properties tab to find the server settings section, encryption settings section. Notice we will observe that the server side encryption using SSE KMS is enabled on this object. Okay, so here I have selected this here, clock.png. I am in the properties tab here. Okay, so let us see the server side encryption. Yeah, here it is. The encryption key AR number ID is here, along with the server side encryption with AWS Key Management Service keys, which is a SSE KMS. Okay, so here our task is done. So now in the task 3 we will be attempting public access to the encrypted object. Attempt to open the image by using the S3 URL in the object overview section. Okay, so I think this is one of a technical task here which we will be performing here. So let us go back to the object URL here, copy link address, paste it. Okay, so the first step is that we will receive an access denied error here. Let us verify. Yeah, that is correct. We received an access denied error here, and so now is one method to provide the public internet access to an S3 object. However, by default, when you create an S3 bucket, public access to objects is not allowed. The default block all IP address access. Security settings is applied to this bucket and all objects stored in it. Keep the browser tab open because you will return to this page in a moment. So I think we will just keep this open here. Okay, so now what is the next task is modify the public access permission for the bucket here. So now in the breadcrumbs which are located in the image bucket here, we will go to the breadcrumbs. Okay, choose the bucket name which contains image bucket, choose the permissions tab. In the block public access, choose edit, clear all, block all public access, and choose save. Okay, so we are already here in the image file folder here. So anyways, let us return back. Okay, so now in the breadcrumbs permissions tab, so apparently block public access is here is on, so we may have to turn it off. Edit, here it is turned off. save changes. No, wait. Block. Let me recheck it. Permissions tab. Okay, edit. Block all is save changes. Okay, so let me write confirm here. So now it's successfully we just changed here, and now for the next task we will choose objects. Okay, choose a link by image bucket and use the permissions tab. So now to modify the access settings for the objects, we choose the link for the bucket name that contains the image bucket and choose the permissions tab. Okay. So here I have to search for the objects ownerships. Okay. Under object choose edit, choose ACLs enabled. The bucket has the bucket owner and force setting applied to the object owner. When bucket owner force is applied, use I have to use bucket policies here. I think like bucket permissions tab. Bucket owner. Okay, I have to go in this on edit ownership tab here. So the image bucket where it was selected, I have to go to the permissions tab here, and then I have to go to the object ownership tab like there it is indicating here. Under object ownership choose edit, choose ACLs enabled. Okay, object ownership bucket owner reinforcements. Okay, ACLs enabled here. Checkbox for the acknowledgement key bucket owner preferred, and okay, it is saying a checkbox. I acknowledge that ACLs will be restored, bucket owner preferred, and keep bucket owner preferred selected and choose save settings here. Okay, so save changes. Okay, I have successfully added it here. Object step, then select clock.png. Okay, objects here. Next thing is choose actions and make public using. Okay, actions. Right. Make public using ACL. Make public using ACL. Okay, then choose make public. Okay, so here it is done. Displays to indicate that the okay, so it has been done here. We will now close it. So now for the next is text access. Okay, so now let us refresh this. Okay, invalid argument request specifying server-side encryption with AWS KMS managed keys require AWS signature version. Okay, authorization error I am getting here. Okay, so it's fine, like it has been updated here. A different error display, like just as the lab requirement task was, because it demonstrates. So now we will close the folder where we loaded the S3 browser here. Okay, so now we will move on to the next task here. So I think when this task we will be open the stored in the close this here. Attempt, like in this we will be attempting signed access to the encrypted object here. Okay, we will open the stored and encrypted object in the Amazon S3 console. Make sure we are on the objects tab for the bucket here. Okay, so apparently I am at the objects tab here. Let me just simply click it here or simply refresh it. Here I have selected this here. Then choose the following image opens in a new tab. Okay, well, yeah, here it is. It opens here in a new tab window. So we have the URL above here. So now what is the next task is analyze URL that was used to successfully decrypt the object. Notice the URL tab where the image is open. The format is similar to the following where that dot values contains the following letters here. Like and close the browser tab where the image is loaded and return to the S3 console. Okay, so let us observe this whether it is. Yeah, here it is. Like I am getting these values here, X algorithm and AWS hashing MAC address here with SHA 256 and X Amazon here in the URL, and I am verifying it like it is an unsigned payload here, and with the X Amazon like red credentials like which were in the instructions. Here we are getting this kind of response. So now we will close the browser tab where the image is loaded and return to the S3 console here. Okay, so it opens like so and return the following diagram and description explain what transpired when you requested to open the stored encrypted object here. Okay, so the user requested to open the object. Next, the Amazon S3 noticed that the requested object was encrypted because you because the user were because we were authenticated to the AWS account when using the Amazon S3 console. The signature version authentication information was automatically included in the request. Amazon S3 then sent the encrypted copy of the data that the object was encrypted with to AWS KMS. Then AWS KMS then decrypted the data key by using the KMS key, AWS KMS key, which never leaves the AWS KMS service. The AWS KMS then sent the plaintext data key back to Amazon S3, and finally Amazon S3 decrypted the ciphertext of the data object, allowed you to open the object and deleted the plaintext copy. Okay, so here our task number 4 is done. So now we will be monitoring AWS KMS activity by using CloudTrail. So access the CloudTrail event history in the search box. Okay, so now we will be returning back here. So let me type CloudTrail. Okay, Wait for it to load. Okay, access panel, you don't have permission to access. So event history. Open, choose cloud trail. Notice there are column named event source. Okay. Easy. So let me just find the event source file here. So and then in the search history enter KMS. Okay, so here we have the list of a cloud trail, monitor of Amazon KMS here, event source. Like notice the column name event source. Each time that an API call to an AWS service occurs within the region that you have selected, if that service reported such events to CloudTrail, then the event and the AWS service occurs within the region that you have selected. If that service reports such events to CloudTrail, then the event and the AWS Key service that reported events are listed here. Okay. So like here are the events of these, like which timestamps of it, like at which timestamps they were all performed here. So filter the event history, filter the event history to display all events that the AWS KMS service reported. Choose the drop down menu on the left that displays read only and choose event source. Event source. So in the enter event we search for KMS like this is done. So now we will choose the link of generate data key event name and the event recorded and section and observe details of the events like here in the highlighted. Okay, so I have selected let me just simply open it in a new tab. So here are the details of it, of the lab ID here. Like we will be observing the principal ID here. Okay, principal ID here, like here it is the principal ID of the labs, and along with what other things we need to observe, let me check, like bucket, image bucket here, details, event name. Okay, so event name here is generate data key, like that is true, has been displayed, is displayed here, and principal ID is displayed with the event name and a key ID and a clock.png. Okay, which ID were we supposed to? Key ID of request parameters. So here it is the image bucket here. Here it shows the ID of here. It could be anything. It is in a JSON format here. and the encryption content. Okay, sorry, there it is, the image bucket here, encryption content, and let me just key ID of request parameters. So, here it is, the key ID is here. Okay, so here it is been observed upon. Okay, this event was generated when we requested to upload the clock.png file to Amazon S3. The action prompted AWS KMS to generate a new data key. If you go to the AWS KMS console and look at the key ID of the AWS KMS key that you created in task 1, you will find that it matches the key ID record. Okay, so here is the key ID. Okay. Why is it not opening? Let us just verify it whether it is true or not for the analysis section. Like here it's the key ID. Yeah, here it is, the key ID. Here it is 12375. 12375. Yes, the key ID here matches with the request parameters, like it is telling true. Like that specifies the app ARN number here, ID of it. Okay, we can close this for now. And after it receives the data key from AWS KMS, the event details also list the identity, principal ID of the user or role who made the request. Okay, so now analyze and decrypt the event. In the breadcrumbs at the top, choose event history. So now we will be using task number 17 here. We will be analyzing the decrypt event. In the breadcrumbs at the top of the page, use event history. The event should be filtered by the AKMS event source here. Okay, so now we will return back to here. Click on event history again. Wait for it to load. Event history 33 and okay, so let me just close this, refresh this one again. Wait for it to load. So I am already in the event source, and okay, we have two decrypt folders here with different timestamps here. So choose in the breadcrumbs, choose event history. Note the event should be filtered by the kms.amazon.com event source. Okay, both of these are in here decrypted. So which one it is telling me to, like I have two of these, like so let me just event history. So let me just check this one. User for decrypt. Okay, it is the user ID is decrypt here. So here, so what do we have to observe? Choose a link decrypt event name as you did previously. Observe the details in the event record section. This event was generated when you successfully opened the clock.png from the AWS console. Notice that the record again details who made the request, which AWS KMS key provided, the unencrypted data key back to Amazon S3, and which S3 object was decrypted with the plain text data key. Cloud trail logs all AWS KMS API activity. By evaluating these log entries, you might be able to determine the past usage of the records. Okay, so like it was requested by me, attributes AWS internal and decryption. Yes, I was able to decrypt it here, like the symmetric default. Okay, key material ID. Okay,
Okay, I got the read-only access with the account ID here 12375, like the API call was here. So I had to select the timestamp of the recent timestamp in which it was successfully loaded. So here apparently the first one here was not uploaded successfully because we were testing it, and the second one timestamp, which recent timestamp in which the clock.png image was successfully uploaded or checked via the image settings search history. We need to select upon the recent timestamp of the decrypt section here folder here. Okay, so from here our task here is done. So now encrypting the root volume of an existing EC2 instance. In this task we will encrypt the root volume of an existing EC2 instance. To encrypt the unencrypted volume we will need to complete multiple steps. The following diagram here shows, like here lab instances here. Okay, so first of all we have to stop the instance, detach the volume, create a snapshot of the unencrypted root volume, create a new encrypted volume for that snapshot, swap the encrypted volume in as the new instance root volume, and finally start the instance here. Okay, so for this next task, I think this is a bit, we will have to go back. Let me just close it. We may have to go to the EC2 instance here. EC2. Okay, selected here. EC2 instances. Wait for it to load. We have apparently one instance is running here. So let us check. Okay, we have the lab instance running here. Okay, the specific, like we have to go to the storage. Here we have the volume ID here. Let's check whether it is encrypted or not. No, it is not encrypted. So let us check what the search box of the service. Search for and choose for EC2 done. In the navigation pane, choose instances. For the lab instance, choose the storage. In the block devices section, notice that the volume that is attached indicates it is not encrypted. This is the root volume which contains the guest OS installed. Okay, so we may have to stop the instance and okay, we may have to stop the instance here. Okay, so it is not encrypted. Okay, so it's fine, I guess. It is attached and it is also in use. So apparently we may have to stop this instance here. Stop instance. So here I have stopped the instance here. So now return back. Create a snapshot of the root EBS volume of the existing instance. Choose the storage tab in the block devices. In the block devices section, choose the link volume ID. Okay, this is a very tough task here. Apparently, I may have to go back to the instance here. Yeah, let me just open it in new tab. Volume ID here. Wait for it to load. Select. Oh god, I use. Okay. So it is status is in use. No alarms and attachments are attached to it. It is completed and not encrypted here. We will have to add a tag here. So let me just first verify. Choose the storage in the blocks, choose the volume ID, choose the link of the volume ID for the volume ID again. Okay, exactly this again. Note the availability zone where the volume exists. For example, US. You need this information in a moment. Okay, let me check the zone. Okay, I have here, it is the zone. Use 1 is Z3 US East 1E. Okay, choose actions. So let me just go back. Actions. What do I have to do? Actions, and I have to create snapshot. Okay. Add tag. Okay, so choose add tag. Okay. So now enter key. I will be entering name and unencrypted root volume. Okay. And now the next step is choose create snapshot. Here I have created a snapshot here. Strange. Create an encrypted volume from the unencrypted. In the navigation pane under elastic block store, choose snapshots. Choose the link. Okay. Okay, so I have to select it here. And oh sorry, I have to go to snapshots section here. Okay. Oh sorry, my mistake. I was on the wrong side here. So elastic block store, choose snapshot, choose the link for the unencrypted root volume snapshot ID that you just created. Wait until the status of the snapshot shows complete. Okay, so the snapshot status here is completed. Okay, so now moving on to the next step here is notice that the encryption status of the snapshot is not encrypted. Okay, just check snapshot status completed and encryption status here is not encrypted. Okay, so now choose actions, create volume from snapshot and configure the following. Okay, actions, right, create volume from snapshot. So it has availability over here, so it is an unencrypted root volume. So and I think so action status is not encrypted. So actions, create volume from snapshot. Here are we in the volume settings. E. We will be encrypting this volume. Let me check whether what is in the AWS details of like what zone am I in. So from that, based on that, I can just follow up on it. Choose available where the existing volume exists. So okay, so existing volume of R exists in use 1 USE1 AZ US East 1E use 1 A dash AZ3 US dash East 1E. Okay, so my KMS key I will have to select here for it. Okay, and the KMS key honors details here. Let me go through the instructions again. Choose my KMS engine, choose create volume. Okay, create volume, unencrypted. So now label the volumes in the navigation pane. Elastic block store, choose volumes. Here we have two volumes here. Have I selected anyone? Okay, with GP2 and one is GP2 and one is GP3. So let's one is encrypted and the one is not encrypted. So one is initializing here in the state. So what we need to do, notice that two volumes are for the volume with the volume state of in use, change the volume name. Okay, let me just check which one is the running condition. So in use and one is available. One is initializing here. Which one I have to select? For the volume with the volume state of in use, change the volume name. Hover on the name field and choose the pencil icon and in use. Okay, so which one is in use? This one is here in volume state is in use and it is not encrypted here, so we will edit it. Let me just copy this, paste it, hold unencrypted, which is in use here and completed one. The other one is initializing here. His state is not unencrypted. Okay, all unencrypted root volume here. Okay, we have choose save. We follow the same steps in the change the name of the volume with the volume available, new encrypted volume, root volume. Okay, let me just copy this one up. So let us check which one is encrypted here. Here this one is encrypted here. Okay, new here is selected. Swap the root, select all, and then choose actions and detach volumes. Okay, all, select actions. What we have to do is detach. Okay, detach volume. Here the unencrypted one we have detached the not encrypted one here, and now what we will be, the new encrypted one we will attach it. New encrypted volume, actions, attach volume. Let's just complete this. Attach volume and configure for instance. Choose lab instance stopped. Okay, instance, lab instance stopped. Okay, device name. So what will be the device name is /dev/xvda /dev/xvda. Okay, this is our, and now we will choose to attach volume. So here we have attached the volume here. So okay, status and initialization, it is initializing here as of right now with the KMS key ID here. Notice that the root volume is now encrypted. Return to the instances screen and select lab instance, choose the storage tab, and notice that attached volume is now encrypted and has a AWS KMS key ID. Okay. We are able to successfully attach it. So let me just refresh this instances here. We have to return back to the instances key here, and now we have to check out for it. Okay. Strange. I'm getting this strange error here. No matching instances found. Let's just return back to the volumes tab. Like initialization is completed here for it. So it should be running right by now. Notice that the root return to the instances screen and select lab instance.
supposed to return to the instances screen. Okay, so from here alternative approach we can see it from here, the lab instance attached resource here. Like, you don't need to worry if the instances don't load, we can alternatively select attached resources from here for the lab instances here. Okay, so instance state is that like it has stopped here anyways. I have to see whether it is encrypted or not. Yes. Okay, sorry, storage tags. Yes, here we can see that it is encrypted here. Like, sorry for my apologies for not observing upon. We could simply just check that whether the lab instance resource was attached to it or not. So now for the next task is disabling the encryption key and observing the effects. In this task, we will temporarily disable the AWS KMS key that we previously used to encrypt an object in Amazon S3 and encrypt an EBS volume. We will then observe the effects that disabling the key has. Disable the AWS KMS key. So choosing. Okay, so let us just revert to here. Key actions. Customer managed keys and my KMS key, and then choose key actions and disable. Okay, key actions and disable to confirm. You have to select for the checkbox. Select the checkbox, confirm that you want to disable this key, and then choose disable key. Okay. So here the key is disabled as of right now. Now try to start the EC2 instance. Navigate to the Amazon, select lab instance, and then choose instance start and start instance. Okay. So here I have selected the start instance. Stop. Okay, instance failed to start. Okay, so it will refresh it again, and like instance says unable to start here because we are disabled the key here. This is the reason that it has failed to start the instance here. Okay, so try to access the S3 object by using the object URL. Navigate to the Amazon S3 console. In the navigation pane, choose buckets, and the image fails to open and a KMS disabled exception error displays. Okay, so now we will be moving to S3 bucket. I think this is one of the most technical tasks I have encountered as of right now. This lab will take a lot of time for the understandings because we have to set up the key KMS along with an OS based system here. So I think this is the first step. Select and then choose open. Yes, we have got the error here, like KMS disabled exception here. Error displays even though this approach to decrypting the object was successful for your earlier in the lab. So now we will analyze the CloudTrail event history. Okay, so now we will CloudTrail, navigate to the CloudTrail and event history. Choose the link of disable key event name, examine the event details. Here show you the examine the start instances. So now we have to navigate to the CloudTrail console. Okay. So choose the link for the disable key event name. Okay, disable key event name. So here are the details of it, because even though the role was assumed, like we were able to get a disable key event name here and with the error messages here. As it is observed, examine details to show you disable KMS key a few minutes ago. Examine the star instances event which occurred just after the disable key event here. So here it is, like start instances event. Okay, so now we have to check the start instances event here. Okay. So here we have the details of it. For the start instance event in a JSON view format, it should. And now for examine the create grant event which occurred just after the start instances event. Okay. So now we have to wait for it to load. And this loading will take some time.
So access denied exception anyways. So here we can observe it is like disabled exception error we got here, like since it assumed that AWS key role was at first active, but now apparently it is not active here. So which is the reason that the read only and the request IDs were all denied exceptions here of it. So now we have to return to the AWS KMS and re-enable the my KMS key custom managed here. Okay. So I have returned to the AWS KMS here. Let's wait for it to refresh. Like we have got the errors in these files here, like false here.
Like disabled exception error we got here in this instance, and for here, like for start instances we get a null error here because the instance was able to start.
And for disable key, error code like read only was false here, and error code we got nothing for. So now we will enable it. Okay, key has been now enabled. So now EC2 console and start the lab instance again. Okay, so I have returned here. Let me just refresh it again. I selected the lab instance here. So what I have to do is start instance. Okay, now I have successfully initiated the starting of this instance here. So now let's wait for the instance state to work. Now status running here. Easy to console start. The instance successfully starts. Important, before you submit your work for the lab, wait for the instance state to display running. Okay, so now it has been displayed running here. So now here are all of our tasks are completed for this instance state. So let's re-verify. Okay, so now let's submit the work here. Let's see how many marks we get. Although all tasks were completed, so let's hope. Submission recorded. Okay, all tasks were done complete successfully. I got attained full marks for it. Okay, so let's see the submission report. Like we were able to get these all tasks done successfully. Okay, evaluating task AWS key was created successfully, and testing report like it was success. With my KMS key was found with it, and then evaluating for task 2 S3 encrypted for object was found. Okay, so this was also a success. Success, and encrypted object name clock was found in the image bucket here. Okay, bucket and object public access enabled, like this was also a success. Your evaluations, all of these tasks was done, like we were all able to perform all these tasks in a timely environment. Although it was the duration of this lab was 75 minutes, we were able to complete it in approximately, I think so, above 60 minutes, I have to say. So now it has done successfully with a total score of 30 out of 30. We will now see you in the next one. Next, I will be performing the module 5 knowledge check here, and make sure you like and subscribe this video and share it with your peers as well. And I hope to see you next time. Wish you all the best and happy learning. Thank you very much.